Hello all, welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all, welcome to episode 23 of Firecode Tech. On this episode, we're talking about fire protection plans. Following in line with our series about common topics in fire protection engineering and building a basis for a young professional, I wanted to talk about common themes, details, schedules, and the scope of fire protection engineering plans and shop drawings. So that's a lot to unpack, but I wanted to help build the basis for young professionals to have knowledge about the industry and common practices around generating shop drawings or engineering drawings for fire protection. Don't forget to subscribe so you never miss an episode and follow us on social media. Oh, and one big favor, if you could help me out, go and rate us 5 stars on Apple Podcasts and send a review if you would. All right, let's get into the episode. So let's talk about what is a fire protection plan. Well, a fire protection plan might mean something different for an engineer or a engineering technician, depending on what you are contracted to do, what you are contractually obligated to provide. So, for those who are unaware, the design side of fire protection involves engineers and providing documents with broad criteria and scoping in regards to local jurisdictions and setting up a kind of broad scope in order to give insight for systems and specific components that are required to make a building fire and life safety compliant. This differs from shop drawings, which are usually from a contractor who is showing details and developing drawings in order to detail the specific layout of a system for the purposes of constructability, usually. Or also, they can be generated for permit and so to send to building code officials or owners or engineers and architects for approval in the submittal process. So for the rest of the conversation, we'll say design fire protection drawings in reference to what architects and engineers produce, and then shop drawings for the more constructability oriented drawings that are produced by a contractor. The process of fire protection engineering from the conceptual stage to all the way into constructed and acceptance tested looks a little bit like this. So the architect and engineer produces design drawings. These drawings are meant to be produced in order to give the general contractor and subcontractor project criteria and functional requirements in order to design the fire and life safety systems, or more broadly, all of the systems required to not only bring a code compliant building, but one that functionally meets the requirements of the building owner. Construction documents occur after the project has been bid and the bid has been accepted in the typical design bid build case. For those of you who don't know, there are multiple project delivery methods. There's design build, in which the contractor and the architect and engineer work in tandem as a joint venture of sorts. And then there's design bid build, in which the architect and engineer serves as a representative of the owner, and the general contractors send in their bids and competitively vie for the contract in order to win the contract, and those bids can be evaluated and selected on a variety of reasons, but typically the biggest and most important reason to select the GC is cost and quality. So typically, the fire suppression contractor will send in their bids, which are estimates of labor, materials, and other cost item factors within the job. And so that's really before the shop drawing phase, but just trying to describe some of the life cycle of the project for fire protection. So after the bid is accepted and the subcontractors and general contractor is awarded the job, then the shop drawings will be produced. Depending on the fire and life safety system that is being constructed, the shop drawings will be designed and modeled at different times during the project life cycle. So now that we've given a broad overview of what shop drawings and what design drawings are, let's talk about what are some of the common components that might go into these fire protection plans. So for fire protection engineering drawings, there is a variety of detail level that can be provided. Depending on scope and complexity of the project, there can be a very great level of detail provided, including sprinkler head layouts and some more detailed components of the fire and life safety system that might not be as common on smaller to medium-sized projects. But for the conversation's sake, let's say that, I'll give an example of common industry items that are provided, common practice within the industry, level of detail items that are provided. But keep in mind that there is a wide variety of what different consulting firms provide for their fire protection plans. Some people refer to fire protection as only in regard to the fire suppression element of the building, but when I say fire protection, I mean all fire and life safety systems in a building. So, as a fire protection engineer, I am looking to holistically review and detail the systems involved in fire and life safety and represent them in a way that they can be bid. So there are some common details to all kind of construction drawings. Whether it's a shop drawing or an engineering drawing, there are certain items that are very typical throughout these drafted drawings. One of those items is the north arrow, which is basically orients the viewer of the drawing to the cardinal direction displacement of the building. Generally, it's fairly typical to have north be plan north on the page, which means that the top of the page is the direction of north. That is not always the case, and so you want to check the drawing which you're looking at. The second extremely common item is the graphic scale. For a drawing to be created to scale means that you can obtain dimensions from the drawing utilizing the scale that it is drawn at. Common graphic scale sizes are an eighth of an inch equals 1 foot, a quarter of an inch equals 1 foot, half an inch equals 1 foot, or an inch equals 1 foot. Depending on how big the building is, they can also scale much larger. So generally, eighth inch equals a foot is pretty standard, and so if the building is bigger than what it takes to put on one sheet at an eighth inch equals a foot, usually they will divide up the building in however many sectors it takes in order to get a plan of the entire building on a scaled drawing that equals an eighth inch equals a foot. Completed design drawings will have elements of fire protection systems like main lines for fire sprinkler systems, fire alarm notification and initiation devices, fire alarm and other system control panels and annunciators, textual notes describing what needs to be done for the project extents or clarification details on a sheet. So drawing naming conventions vary, but by and large, the industry follows a set standard of abbreviations for different floor plans or different plans from different engineering and architectural disciplines. So there are C drawings, which are civil drawings, A drawings, which usually refer to architectural drawings, I for interiors. For fire protection, you could have FP drawings for a combination of fire alarm and fire suppression. You could have FX for fire suppression, FA for fire alarm, E for electrical, M for mechanical, MH for HVAC, P for plumbing. Oftentimes there are G sheets for life safety or for general documentation at the front of the drawing set. Plans are usually in the 100 series of drawings, and drawings generally go from 100 series drawings to about typically 700 series drawings. And so if you had 3 floor plans, you might have drawings named FP101, FP102, and FP103. If you had a second floor with one drawing, you might have FP201. And so there is a specified sequence of drawings in the kind of conventional architects and engineer layout. And so usually plans is in the 100 series, sections in the 300 series. Another way you could break up elevation is to have subsequent levels adding a 10 place number. So you could have like 111 or 112 for second floor drawings. Details are generally on 500 series drawings. So FP 501 might be where you locate some details, standard details for fire suppression piping or fire alarm wiring details. 400 series drawings, so FP 401 is where you will have your enlarged plans. Enlarged plans are a much closer look at a specific area within the floor plan in order to give more detail and more nuance to what you're describing or showing. Programs like Revit will automatically cut an enlarged plan if you use the view references or the callouts correctly. Sections, by that same token, are a vertical slice of the building in order to illustrate a section of the building as if you were standing looking at it in elevation and not in plan. Plan is in reference to if you are looking at the building from a bird's eye view, looking down on the building, and elevation is how you would see a wall, standing up and looking at a wall. 600 series drawings are usually for schedules like fire suppression or fire alarm riser schedules. And 700 series drawings are generally for matrices. So if you have a fire alarm matrix or a foam controls or a special hazards matrix, they would be FP 701, 702, 703. The reason for a fire suppression riser diagram is to give greater detail than what you can see in plan. Sometimes if you have a building with a complicated system, it could help the contractors bid the drawing in order to show vertically how the system proceeds through the building. The building can have multiple lead-ins and places where the water supply comes in. So all of these details and designs are to help the contractor be able to bid the system involved and to provide a code-compliant life safety system. Matrix, typically it's the fire protection engineer's job to specify how the fire alarm system behaves, so the inputs and outputs that make the fire alarm system react how it's supposed to. These requirements for what needs to be monitored and what the inputs and outputs need to be can be found in NFPA 72. Shop drawings vary greatly based on what system you are designing, but I have the most experience with fire suppression drawings, more specifically water-based systems. Shop drawings have a list of requirements for working plans as they're described in Chapter 28, which is Plans and Calculations in the latest edition of NFPA 13, which is 2022. In section 28.1.3, there's a list of over 20 items that are required to be on working plans. Depending on the project, some and many of these details may not be required. But for new construction, you always want to require as many of these details as the contractor can provide. Some of these details for shop drawings or working plans are the name and address of the property, the telephone and address of the contractor, the compass and the graphic scale, like we talked about before, as some of the standard graphical details. Water supply information, including location, type, size, dimensions, capacity, configuration, elevation, static pressure, flow rate, residual pressure, and floatate locations, dates, and sources. So the reason why that is such an involved requirement is because those are all the details that are pertinent for hydraulic calculations, which is how you're going to size and design your system. So as you can see from these requirements, we are looking at all of the pertinent design criteria and sprinkler information in order to show the layout and location of all the sprinkler heads and mains and hangers, and then also show our work on how we calculated the system, what's the water supply like, and all of the factors around the design of the system so that we have good documentation and justification of why the system was designed the way it was. I think that's it for this episode. There's a lot more that I could talk about for shop drawings, but we'll save that for next time on Fire Code Tech. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.